Okay, you won't believe where I have to go to actually solve this kind of question. I searched everywhere. There is some very advanced information about, minimal polynomials of this thing. So x is equal to cosine of um, r times 2 pi upon n, where actually I should say p times 2 pi upon n, where p is a number that is co-primed n. So there's a whole um, I should say theorem, like a set of theorems related to the minimal polynomial of this thing. So right, one of the theorem was like the cyclotomic polynomial for the primitive roots of unity. Those polynomials, when you like divide them by z power whatever degree you have, but the half of that. Okay, actually, yeah, the half of that, and you make them symmetric because they are already palindromic, so you just have to make them symmetric. And then once you do that, you will get a polynomial, not kind of a polynomial, I would say something like a polynomial with negative integer powers as well. And then you have to collect terms, and z power k plus z power negative k, those terms can be written as a polynomial of x basically, right? So the sum of those two terms, so z power n plus z power negative n, this is like t sub n of 2x actually, right? So you can do something like that. But am I going to do this, right? Am I going to actually find that polynomial no, I won't. I'll just use one of these theorems, which basically says that the minimal polynomial of this kind of term, right, for this value, uh, that will have the degree phi of n, that thing upon 2. So phi is the Euler-Tauschant number. It's a part of the number theory, but yeah, okay, you have to use it. And there's also some stuff about sets and like the unions of sets. And yeah, cyclotomic polynomial in itself is quite a complicated thing. And then using that to figure out this minimal, no way am I going to do that, right? I couldn't find any other method that actually could be generalized. Uh, but yeah, that's the only efficient result that I could get, that the degree of our minimal polynomial, that will be phi of n upon 2, and this is only for minimal polynomials of this kind of thing. Okay, cosine of some number that is co-prime to n, that times of 2 pi, and I think about it. And also like the polynomial that we'll actually get is basically this thing, product of x minus cosine of so r upon n times 2 pi, where the GCD of r and n is equal to 1, and you got all of these r values, right? uh yeah, actually not all of the r values. Your r just goes from, what was this, 1 or what? I think it was 1. Yeah, wait, was there 0 involved in this thing? I don't think so. No, there was 0 wasn't involved, not in that. Okay, so it just goes from 1 till n upon 2. So yeah, uh, and okay, n upon 2 may or may not have this thing, but you get the idea, right? So like, okay, r is less than or equal to n upon 2, right? And it should follow this rule all of the time. So, and this is a product, by the way. This polynomial you will get, it will have integer coefficients. And yeah, honestly, it's very weird. How did this happen? Why is this having integer coefficients? There are a lot of questions in my head. There are a lot of theorems which I didn't prove. I just saw them, copied them, and tried to apply them. But yeah, and there is a way to do this. That's what I'm saying. That this can be done. Just the thing is, it's like its level is too high for me right now, and I don't have time to do things like these. Okay, neither do I have time to do things like these. The seventh question. So you remember, I wrote this using a translation in the in a different form. So all the fifth and fourth power terms, those were gone. That was progress, cool. But after that, what I was supposed to do is that I should have wrote this as the sum of squares. And yeah, that Like, how do you get that thing? How do you even uh, understand what to do when you see that it's nowhere obvious why we should write it as a sum of squares? Why should we should even look in that direction? Why not something like a square plus some, kind of constant, or something like that? Why not that? Why the sum of square? Why not just something that is just having the minimum bigger than zero? Because not all things can be written as sum of square plus some constant. No, sometimes it's just that the function, so whatever polynomial function you have, that is just positive, but it might not be like that, right? So yeah, what about those kind of things? Are there no such cases? So yeah, right. How do you even solve these kind of questions at the first time? It's not possible, right? For someone like me, at least, it's not possible. Without proper theory, you cannot solve this. Like, how would I even solve this? No way, right? Okay, I think this book is, yeah, it's just too much for me to handle right now. Maybe after 2 months, I would go back to this thing and just solve this book once and for all. But not right now, because I have other stuff to do, which is far more important than figuring out a bunch of theorems, which I will never use, right? Most likely, I will never use these things because, yeah, I've never seen these being used throughout the 2 years that I have spent. Never seen this being used in the syllabus we were taught. So, not important for our syllabus. That's what I conclude from that, right? And I mean, if this was something that was something that would make calculation easier, or something that would make my life easier somehow, right? A bunch of theorems that make a set of problems that are very routine, or yeah, something like that, that would enable me to solve those kind of problems, which actually do come, right? So do come sometimes. Then I would definitely learn that thing. But doing this, I just felt like, oh God, I'm spending so much of time in doing these things which won't matter, and I'm not even enjoying that thing. Why am I doing this? That's the main question. Like, okay, somebody told me to do Pathfinder, that's why I'm trying to do this thing. I thought that, hey, it could have good problems, but turns out like all these problems are way too high level, and they require hours of searching on the internet to even solve a single problem. There's no way I'm going to complete the whole book, right? And the understanding that I will gain from this thing, it's not useful. Why even do this, right? So yeah, I'll just try to do as much as I can in this section, and this will be, I guess, the last video because it's just too much, right? Okay, anyway, so 8th and 9th, we can do these because of this nice result that we have, that the degree is well known now, right? So now we know what the degree is. So first we'll deal with sine of 10 degree. Okay, that can be done as cosine of 80 degrees, and then 80 degrees like 4 times of 20 degrees, which is pi upon 9, right? Pi upon 3 upon 3. Makes sense? But we want in this format 2 pi upon n times r. So this thing can be written as 2 times of 2 pi upon 9. So what is n in this case? It's just 9. So we want a quotient of 9 and that thing upon 2. Quotient of upon 2, sorry. Quotient of 9 can be calculated as 3 times of 3 minus 1, which is 2, right? Okay, you will understand this, what I'm doing, when you actually learn about the quotient function, right? If you actually solve this book, then you will have a number theory section, right? I'm not, look, I have not seen that section, but from my past experiences, I know how the quotient function works. So yeah, this is just equal to 3 times of 2. So 3 times 3 minus 1, which is 6, and that thing upon 2, that's 3. So the degree of our polynomial should be 3, right? That will be a minimal polynomial. And exactly, we got that as the degree. So we actually solved the 8th question, right? Yeah, that is our degree of the polynomial. For the 9th question, we want to construct a polynomial. These degree rational coefficients, one of the roots is sine 20 degrees. which is cosine of 70 degree, and 10 degree is like pi upon 18. So we are just dealing with 7 pi upon 18, which is like 7 times 2 pi upon 36. So in this case, n is 36. Look, 7 is co-prime to 36. So n is just 30. You get the idea. So 36, what is that guy's quotient number? 36 is 2 power 2 times 3 power 2. The quotient is just going to be 2 times 2 minus 1 is just 1 times 3 times 3 minus 1 is 2. And that thing upon 2 is what we look for. So the degree should be 6, right? So we want a 6-degree polynomial. And guess what? The last time we tried this out, we did get a 6-degree polynomial, right? So yeah, we'll just do that. Okay. Yeah, right. So sine of 20 degrees. What do we know? Like, okay. We first of all need a cubic for, oh, okay. So sine of 60 degree, that's going to be 3 times of x minus 4x cubed. But sine of 60 degree is just sort of 3 upon 2. So we just want to square this, and that will give us our 6-degree polynomial. Cool. So 3 upon 4, that's equal to the square of this guy, which is, so 16x power 6 plus 9x squared minus 12 times 2 is like, oh God, 24 x power 4, right? Cool. So then just got 3 is equal to 64 x power 4. Hey, that's not, oops, it should be x power 6. Yeah, x power 6 is what it should be. That's x squared, it's x power 4. Cool. Understandable. So which is 64 x power, God, no, x power 6. Okay. Minus, so you got like 8 and 16 is just 96 x power 4. And you got 36x squared. So the equation is just this guy. 64x power 6 minus 96x power 4 plus 36x squared minus 3 is equal to 0. So it only has like square terms over here. Huh, interesting. But that would make the negative version would also satisfy this thing. Yeah, it would, right? Of course it would. Okay, that's awesome. Okay, 10th question. Construct a polynomial equation of least degree with rational coefficients. One of the roots is cosine of 10 degree, other one is cosine of 20 degree. Okay. Right. So one is cosine of 10 degree, other is cosine of 20 degree. Once again, we know what 10 degree is. It's just, oh, hey, that's actually not that hard. Oh, wait. Once again, like, what's the value of n that you got? Ah, that's weird. Hey, isn't this like the minimal polynomial? What was this minimal polynomial for? It was for sine of 20 degree, which is cosine of 70 degree. So cosine of 7 times 10 degrees, right? This is also 10 degree and that times 1. So, right, okay, 10 is just like, okay, 2 pi upon 36. 1 is coprime to 36, 7 is coprime to 36. This also has cosine of 10 degrees as one of its zeros. Interesting, isn't it? I guess. Yeah. And this actually, I mean, yeah, it follows the same equation because, okay, 3x minus 4x cubed. Wait, actually, no. 4x cubed minus 3x. That's equal to square root 3 upon 2. So it's just, yeah, 3x minus 4x is equal to negative square root 3 upon 2. So the square stuff still works out. And that's by the same equation. So, yeah, A is same as in 9th. And what about B? And then you got what? Cosine of 20 degrees, right? So yeah, that's like, hey, we already have done that once, I guess. Wait, we did 80 degrees, right? That was just 4 times of pi upon 9, which is, okay, 2 times of 2 pi upon 9 that we did. And okay, now we want 20 degrees, which is, oh god, yeah, that is pi upon 9. Wait, that's 2 pi upon, oh, no, that's not nice. That is not nice. Wait, something's not correct about this. That was 80 degree, this is 20 degree. Okay. Pi upon 9 is what 20 degree is. So, oh god. In this case, n might be a different thing. It's actually like, wow, that's not expected. The first guy was like cosine of sine 10 degrees. That was just cosine of 80 degrees, which is cosine of so 2 pi upon 9. That times 2, right? Okay. In this case, we are just dealing with pi upon 9, just pi upon 9. It just has, oh God. Right. So where did that go? Uh, Cosine of 20 degrees, of course. Okay, that's like 1 upon 2 and everything. Okay, I understand that. Oh, it is going to be negative of, yeah, that's understandable. It's not that bad, I guess. Right, we can try to do this thing. So it's pi upon 9. We would like 2 pi upon 18. I guess that's how it's going to be. 2 pi upon 18, right? Sure. What's the quotient of 18? So 18 is like 2 times 3 squared. So, 3 times of 2, but then that's just 1 and nothing upon 2. It's still 3. Just the thing is, now you just got like, yeah, instead of that 1 upon 2, you got negative 1 upon 2. Because for cosine, it's not 3x minus 4x cubed, it's instead 4x cubed minus 3x. So just have to make this constant the opposite, right? So 8x cubed minus 6x plus 1 is equal to 0. That should be doing it. So that's 10th. And then 11th, construct a polynomial equation. One of the roots is tan 10 degree and tan 20. Now the problem is I searched, but I didn't get a condition like this one for this thing, tan 10 degree or tan 20 degree. So yeah, I don't know. I don't know how to do this one, right? What would the minimal polynomial be? I have no idea. I mean, I could try to do this thing, but chances are it will just be not good, right? I mean, even if I did the triple angle formula, I just get like 1 upon square root or something like that. Not worth doing. I don't think so. Yeah. Well, yeah, that's the thing. It's not worth doing, and I also don't know how to find the minimal polynomial. So 11th we'll just have to skip. And now that I know what I actually have to go through to even get to this kind of condition, yeah, I'm not going to do this thing. 11th, just not going to do that. So miss. 12th. Okay, construct. Okay, should this skip? I don't know. Because I didn't actually miss the thing. Yeah, I mean, it wasn't that I tried and then I couldn't do it. It's that I'm not doing it. 12th. Construct a polynomial equation with rational coefficients. Two of the roots are sine 10 degree and cosine 20. Didn't we already do that? Cosine 20 degrees? Oh, okay. Two of the roots. So, right. That's interesting. So wait, sine of 10 degree, that is, oh God. Oh, that's not good. Oh shit. That's not good. Yeah, like you have to have the polynomial, huh? With cosine of 20 and sine of 20 with the roots. That's like cosine of 80 degree. We already did that one, but the unfortunate thing is like, yeah, these degrees are not the same. Uh-huh. Both of these guys. Oh God. How am I going to do that? Oh, okay. I think I know. I know. So look, okay, like using the triple angle formula, like both of these give either 1 upon 2 or negative 1 upon 2, right? Okay, so sine of 30 degrees is 1 upon 2, cosine of 30 degrees, 60 degrees 1 upon 2, but then the format is inverse. So yeah, okay, just combine these two together. Or maybe not. That will give us a 6-degree equation. That's not what we want. Oh God. No, we definitely don't want a 6-degree equation. God, that doesn't look good. But that's what it is. It's gonna be a 6-degree equation, right? Yeah. Like, yeah, the thing is, the minimal polynomial, right? You got this thing. Okay, if you've got a polynomial that has both of these as roots, it should just have minimal polynomial as a factor, right? Could there be anything else happening? Like that some factors of this minimal polynomial are not there and some other factors are there and still works out. I don't think that's supposed to happen. Hmm. Interesting. Yeah, I definitely don't think that's supposed to happen. So yeah, like okay, 8x cubed minus 6x squared is equal to 1. Is that wrong to say? Is that not the minimal polynomial? What other things would be there that no, it must be correct. Okay, this is kind of a hard question because sine 10 degrees, it is like that's cosine of 80 degrees, and unfortunately, yeah, okay, that has 9 as the n value, and this has 18 as the n value. So both are different. You can't just plug them in the same formula anymore. Oh god. Now what do we do? Uh, just multiply them together, man. Why do you even think about doing anything else? If there's anything that then it's that, right? There will be other things that are doing the same. Okay, this is weird. That's the same kind of thing that I had in the last video as well. That I didn't know if that would be a minimal polynomial or not. But now I just don't have time for that kind of thinking. I'll just square that and equal to 1. Yeah. So, right, okay, 4 times of, well, just say 4x squared times 4x squared minus 6. Okay, that's gone. So 4x minus 3. That has squared, that's equal to 1. 4x squared, and then you got 16x power 4 minus 24x squared plus 9 is equal to 1. So 64x power 6 minus, you got 8 and 16, that's 96, 96x power 4 plus 36x squared minus 1 is equal to 0. Hopefully that's correct. Most likely not, because there will be something that's weird about this thing. I'm sure of it. Most of the times what I say is incorrect, but let's go with it. Who knows? It might work out. Okay, and 13th is if PQR are the real roots of this equation, determine the possible values of p square q plus q square r plus r square p. Okay, real roots of this equation. You just want the possible values. Why do you ask me that? Oh, okay, so it's like it could also go like p square r and stuff, something like that. Okay, understandable. So you got p square q. You don't have pq square. Interesting. Uh, right. Wanna find possible. Why don't we just figure out the roots themselves? Right? What's stopping us? Minus 6x squared. It's like x cube. We can probably do that thing first. So, okay, think about it. Maybe we can write like this thing. So, x cubed plus 3x cubed plus 3x plus 1, that's just x plus 1 cubed. But then to actually keep it the same stuff, just have to minus 9x squared. Right, and that's equal to 0. Okay. How is that helpful? We can just set x plus 1 equal to u. So that will, make this probably easier. I don't know. Who am I kidding? That is going to make it much harder. Because you will have 9 and stuff over there, and yeah, not worth doing, I guess. Is there nothing we can do about this? Let's just like quadratic over here and not helping. It's not even a cube of something. At least that would have helped. That's not correct. Okay. 1, is that a solution? So you got, okay, minus 1. Minus, okay, no, that's not a solution. 1 and minus 1 could be the only solutions, and both of them fail. So it has no rational roots. Interesting. So then what do we do now? If it has no rational roots? Uh, yeah, okay, that's weird. X squared, let's say. Something cubed. Nope. Not worked with it. Yeah, just it doesn't have rational roots involved. You can't figure out the roots in that case, because if it doesn't have rational roots, all PQR are going to be irrational. That's problematic. So you have to do something else in that case. Okay. So you got p squared q, like summation of p squared q, right? Okay. Hey, you can write the square in terms of, nah, but that would require a square for, that would require quadratic. It's not a cubic. It's a cubic in this case, not a quadratic, right? Uh, then what? You maybe like take p q r common, and then you just got p upon r and stuff like that, right? So the summation of p upon r is what we look for. So this is actually the same thing as summation of p upon r. Interesting. But now how do you figure that out? P upon r. Ooh. Hey, it's just the real roots, huh? These will have three real roots. Interesting. What are the, what's the derivative of this guy? It's like 3x squared minus 12x plus 3. You can reduce that. So it's like x squared minus 4x plus 3. That's the, this guy's discriminant is positive. So, okay, it does have three real roots, it seems. And you need to figure out what this thing is. Summation of p upon r. Wow. This is not going good. Huh. Okay, give me something that I can use. So p plus r equal to 6. Maybe that's gonna work. No, that won't work. Okay, going the other way around, okay, maybe we can do that thing, but the possible value of this thing, huh? Where do I even start on this thing? Are these all positive or something? No, their multiplication is negative. So you can't just, oh, that multiplication is negative. What am I doing? It's not supposed to be 1, it's supposed to be negative in that case. Right, but still it's the same question. So multiplication is negative, addition is positive, pairwise addition is also positive. Nothing that I can get from that. PQ, right? So you can write that as QR and hey, okay, maybe we can do that thing. So write this thing as P times PQ, but then PQ can be written as yeah, okay, that can be written as 3 minus QR minus, okay, like you got PQ and then minus PR, right? Oh, not nice, because that's P squared R now, and yeah, that doesn't help us. Right, it's just moving to something else and not helping us. Something square. You will have that other stuff, so p square r and yeah, those things. How do you even do that? Okay, what if I take p common? So we've got p times pq plus, well, okay, that is p common. That doesn't help. Even taking q common, it doesn't help actually. If p was somehow r, then that would have worked, but it's not. Okay, come on. And these are the real roots of this equation, and it has like three real roots. Okay, other than actually figuring out these values, what choice do we have? The possible value of this thing. Nope, nothing symmetric is working. Was it summation of p upon r? I've never seen that. Two different values that satisfy the same stuff. Something else. What if it's like, okay, starting to think of something, maybe it won't help. Who knows? What if we could actually figure out the solutions, but not in the radical form, but a trigonometric form? What if we could do that, right? So you got, yeah, okay. There was something I saw about using trigonometry to figure it out cubic equations. Maybe you could do that. So if this doesn't work like normally, you have to go for the other stuff. You have to go for trigonometry, right? Okay. Hopefully something nice will happen. Okay, cool. Let's see what happens. So you got x cubed minus 6x squared plus 3x plus 1 equal to 0. Let's write like this thing. X cubed minus 3 times of 2 times x squared. Okay, I need another stuff. 3 times of 2 squared, just 4, and that times of x. And I will also need negative 2 cubed, which is negative 8. But to compromise, right, it's like 12x. You need 12x. And for that to happen, so like plus 12x minus 12x, that's going to be just like negative 9x, right? Yeah. Okay, and then you want minus 8, so plus 8 as well. You got plus 9. Okay, that was nice. Ah, okay, just wait a second. Is that correct? It is. It is actually. Okay, that's awesome. So x minus 2 cubed minus 9x plus 9 is equal to 0. Now we just say x minus 2 is equal to u. So you got u cubed minus 9 times of x is just 2 plus u, right? So 2 plus u plus 9 is equal, or just let's say minus 9 times of x minus 1. So x minus 1 is just 1 plus, sorry, it's just 1 plus u, right? That's equal to 0. So u cubed minus 9u, wow, that's not good. Minus 9 is equal to 0. God, what is happening? Uh-huh. Not looking good. Hey, u cube, okay, you just want to be the cube of something, right? Mm. But how? How can you make that the cube of something? It's like 9, it's not the cube of anything. Even if you break it, nothing will happen. Uh, yeah, I really thought you could use x cube plus y cube plus z cube is equal to x, y, z, but it doesn't work like that. Okay, I mean, I had enough time to learn about depressed cubics and solve them, but like I just skipped the whole thing, thinking that, oh come on, I don't have to learn about it. I will never be using this. Maybe I do have to learn about this. So it's a depressed cubic. There is a formula that you can use to solve this. I don't remember the formula anymore. Neither do I the method. What was the method? But this is very hard. Do I really have to figure out PQR to actually get this thing? Because it's not symmetric. It's not symmetric, unfortunately. And then, okay, trigonometry. How would you use trigonometry to solve this thing? No, it's not possible like that. U cubed minus 3 part minus 9u minus 9 is equal to 0. So I give you minus 9u is equal to 9. And not helping. It's not helping. Mm, it okay, that doesn't have rational roots. This will also not have any rational roots. That won't work. Yeah, then I'm just out of this whole stuff. There's no way we can actually solve this. Okay, what if like I did this thing, p plus q plus r, that's equal to 6. So I just put that in there and then somehow get p cubed from that. So I'm thinking of, okay, summation of p squared times, and then q is just 6 minus p minus r. So once again, you got p squared r. You don't want something like that. Yeah, you don't want that. That's the main thing. Then now what? You will have p squared r in the end, one way or another. How can you actually escape that? Okay, so 13th is also weird. We don't have a method to do this right now other than actually figuring out the values and doing all that. But then it's got squares and whatnot. Nope, not worth doing. Okay, so 13 will just have to be. What if like this was a cube? Okay, that would have worked awesome, but it's not. It's not. So don't put your hope on that. Plus 1 cube is equal to 9x squared. Okay, so maybe x squared can be written in terms of cubes. Okay. If you got like p plus 1 cube or something, that would have worked. It's a cube, come on. It's not gonna work like that. What if I say multiplies by pqr and then you got like p cube q squared r, and using that thing I just wrote p cube as a function. Okay, using like p squared and everything. Who am I kidding? Then just gonna be symmetric times unsymmetric. That's gonna be unsymmetric in the end. It won't work like that. Nothing will. That's a problem. If nothing will work, how do you solve this thing? Right, it's not Qs per hour, right? That summation will still stick. It won't go away. Hmm. Interesting. But whatever. So 13th I couldn't do. It's weird. 14th, the product of the of two of the four roots of the quadratic equation is negative 32. Determine the value of k. Okay, and that's what. God, negative 198. Why? Determine the value of k. What is k? This thing, right? Sum is given. You know what? Okay, product of two of the four roots is this thing, right? And just say that those were you know gamma and delta. So gamma times delta, that's equal to negative 32. Okay, you can also figure out alpha beta through this thing. What is alpha beta gamma delta? The whole product. That would just be negative 1984. So that's going to be negative 1984 upon 32. Hopefully that's a nice value. Oh, that's like 2 times of that, but then you got 19 over there. That's weird. So you got 2 plus 1900 upon 32. So 4, that can cancel that case. Right, okay, so 19 times 25 upon 8. Come on, seriously. Why? That's not nice. 84. Oh, that's not 2. It should not be 1900. It should just be, you got 1920 actually. So 1920 upon 32. Of course, 6 times of that is just 18 and 12. So, okay. So 62 basically. That's equal to 62. Nice. Okay, that's awesome. What else do we know? We got alpha beta plus beta gamma plus, right, the summation of that guy. That's just gonna be equal to what? That's equal to whatever this thing is. So that's equal to k. Summation of alpha, that's equal to 18, and summation of alpha beta gamma. So yeah, this is like 4 terms for that. Actually, you can just write them. So alpha beta gamma, which is 62 gamma. Okay, this is unknown. We don't even use this equation, right? 62 gamma and what else? Plus beta gamma delta, right? So for beta gamma delta, what you want is gamma delta, right? Or okay, let's not do this thing. Everything that involves alpha beta, just take that into common. So you will just have gamma plus delta in that case. Gamma plus delta. Similarly, plus gamma delta is like negative 32 times alpha plus beta. That is equal to what? That is equal to where did that go? Right, that's like negative, positive, negative. So it's negative 200. Okay, so let's try to reduce this thing by 4. No, it's 2. 31 times gamma plus delta minus 16 alpha plus beta. It's equal to negative 100, or you can just say 16 alpha plus beta minus 31 times gamma plus delta is equal to 100. But there's something else we know about alpha plus beta and gamma plus delta, that there's sum. So call this thing m and n. It's got 16m minus 31n is equal to 100. But we know that m plus n, that's equal to, where did that go? It's equal to 18. Cool. That's a linear equation. You can figure out alpha plus beta and gamma plus delta in that way. And then actually you can figure out what, of course, okay, you can actually figure out alpha beta and gamma delta. Awesome, isn't it? Or why even do that? You just have to figure out this thing, product of alpha beta. 2 terms you already know. It's going to be 6 terms. The other stuff, yeah, you can take some stuff common and then hopefully get the thing done, right? Yeah, once you know what alpha plus beta and gamma plus delta is. Okay, so we'll have to actually solve this thing. Got 16m plus 16n is equal to 16 times 18, which is 17 square minus 1. So 289 minus 1 is just 288. Then subtract, you're gonna get 47n is equal to 188. Yeah, I have bad feelings about this thing. 188 upon 47. This times 4, 16, 20. Oh, come on, that actually is nice. This somehow turns out to be 4. Okay, and then just put that in this. You got m is equal to 14 in that case. Perfect. So 14 times 15 is just sorry, 14 and 16 is like 224 minus 31 times what? 4, that is 124. That's equal to 100. Yes, it is. So that's awesome. So you got m and n. What was m? Once again, alpha plus beta, that's equal to 14, and gamma plus delta, sorry, gamma plus delta, that's equal to 4. Alpha times beta, what was that? 62. And gamma times delta is equal to negative 32. And I'm starting to think that maybe actually you can figure out what each should be. So, right, for example, yeah, actually you can. So gamma is 8, delta is negative 4, right? So gamma is 8, delta is negative 4. What is alpha plus beta? That's okay. Sorry, what alpha and beta? 62 is 62. It's like 2 times of 31. 31, is that a prime? I guess it is. It's not level 3 or something. It's not level 7. Yeah, so that is a prime. Wait, what? That doesn't make any sense. That's 62. It's like 2 times of 31, right? That's what we got after doing all of this. Of course. Oh, come on. Really? 31 is a prime number. How am I going to do anything if that's a prime number? Square root of 31 is square root of, let's say like square root of 49 is 7. So just check till 7. 6, no. 5, no. 3, 2, nothing works. So it's a prime number. Oh, that's bad. So you don't know what alpha beta is, but at least you know what gamma and delta is. So that's good. Gamma is 8 and delta is negative 4. Okay, now we can figure out what they want. So we just want to figure out what k is, right? K is this summation. Yeah, you don't want all this anymore. Okay, summation of alpha beta. So start off at the first term, which is 62. 62, and then you got gamma delta, which is just minus 32. Okay, actually no, you know what? Let's do it the proper way. So first alpha beta, then alpha gamma. So alpha times gamma, and then alpha times delta. So that can get written as minus alpha times gamma plus delta, which is 4. Similarly, you'll have beta. So beta times gamma, beta times delta, because beta times alpha is already used up. So that's going to be like minus 4 times beta, right? So minus beta times 4, I guess. Is that the thing? Oh, why am I doing negative over there? That doesn't make any sense. It should be positive, right? Yeah. Yes, it should be positive. That makes sense. Okay, so beta is done, and then finally you got gamma. So gamma times delta. That's the only last term, which is negative 32, right? So you had 1, 2, 4, and 6. 6 terms. 4c2 makes sense. It's gonna be what? It's going to be 60 plus 4 times of alpha plus beta, which is 14. So 56 plus 30, which is 86. That's what this should be. That's what k is. Makes sense. So 14 we could do. So it's what? Once again 86. Hey, so it's like it's from an Olympiad. Wow. And we actually solved an Olympiad level question. Yeah, I don't want to be solving this booklet anymore. If they are going to put Olympiad level questions in there, I am off. I don't have time for these things. Right? What's this symmetric function? Okay, no, I'm just not going to do any of this. So that's it. That's the last video I'll make about this book. That's it. Let's see you in the next video. Not about this book, by the way.